So last time we were talking about a number of things, including significant figures and calculations. Too many buttons. Here, try that one. There you go. So remember, as we talked about, when we do calculations, we do want to make sure that we do end up with the correct number of significant figures. And as we talked about, there's really kind of two different operations that we typically do. We could multiply or divide. And when we multiply or divide, what we're looking for is the least number of significant figures. So your answer should have the same number of significant figures as the number that has the least number of significant figures. As we talked about, pretty much that's like your worst measurement. So that's why you kind of go with the least number of significant figures in that particular case. It is a little bit different when we add and subtract. So when we add and subtract, we're not looking at significant figures, but we are looking at decimal places. And it's still the least number of decimal places is what you want to look for. Really for the same reason. Again, it's kind of your worst measurement, the least number of significant figures. We also talked about that if we kind of do multiple steps, you do want to kind of keep track of everything along the way. You might not want to round until the very end, but you want to keep track of what you did. And really, it's sort of the last mathematical step that will sort of determine what you should end up with. But you do want to think about the other steps along the way. So for example, if you did something where you added first, you would want to make sure that you went to the proper number of decimal places. And as we talked about, that number of decimal places will give you a value that has a certain number of significant figures. And then if you took that number and multiplied it, then you would want to look at significant figures. And that's really where your answer should end up. So kind of in the order of operations, you want to take care of everything mathematically sort of correct. So things in parentheses first, and you want to kind of keep track of it. We want to always sort of give our answers to correct number of significant figures. One thing that really does not affect the significant figures in your answer is if you're dealing with some type of exact number. So if you have some type of exact number, as we talked about, those are things that are counted. Those are things that are sort of definitions, like 12 inches is 1 foot, that type of definition. You don't have to worry about those in calculations if you happen to use them as conversion factors. The nice thing about that is a lot of times if you're just doing conversion factors, kind of like we might talk about today, for the most part, the original number you start with probably is the right number of sig figs for the answer. Again, not 100% of the time, but if everything's sort of in between the calculation steps are all sort of equalities, you're really good with that sort of first number will be sort of the answer in terms of significant figures. Now, the one place where technically speaking, if you do come across a equality that you should look at the significant figures in the equality is if you cross over, as we talked about, between metric and English. So if you do sort of the crossover between the two different sort of units, you really should look at the significant figures in that equality. And in my experience, most of the time, you'll still probably default back to the original number because they'll probably have more in those sort of things. We also, I think, finished up sort of talking about prefixes that we use, right, to sort of move the numbers or make them a little bit more manageable. And again, as we talked about a number of times last time, people oftentimes will, sort of mess up when they look at those tables, when they see a number like this, what it means. So just one more time in terms of reminder, what that is how much there is in the base unit to one of the prefix units like we talked about. So if we were talking about kilometers and 1 kilometer, there would be 10 to the 3 meters, with meters being our base unit. Here's an example, right? 1 kilogram is 1,000 grams, and that is really the same thing. 1 kilogram is 10 to the 3 grams. The base unit here is grams in each of them. 10 to the 3 is 1,000, right? So 1 times 10 to the 3 is 1,000. So it's the same conversion. Same thing here. This is centi, the conversion. I'll do better than I did in discussion the other day, but centi is 10 to the minus 2 there. And again, what that would mean is in 1, for example, centimeter, there would be 10 to the minus 2 meters, or in this particular case, 1 centiliter, there would be 10 to the minus 2 liters. Again, 10 to the minus 2 is 1 times 10 to the minus 2, which means we take the decimal point 2 places that way. And again, that is where the 0.01 number comes from. Any questions on the stuff we talked about last time? Okay. So we'll continue on, I think, from this point here. We'll talk about writing conversion factors. And I think we touched upon this towards the end last time. Really, conversion factors are going to be used in a process in chemistry here where it's referred to as dimensional analysis. And dimensional analysis is a way in which we work out problems, and you're supposed to work out problems in chemistry. And it's where it's really sort of a unit conversion type situation where we show all the steps with all the units, we show the units canceling out. So for example, if we had a particular unit we're starting with and we want to get rid of it, we would do sort of a conversion factor where we would go to a different unit, and the unit we want to cancel would go in the opposite location, and we end up with a different unit in this particular case. The conversion factors come from equalities. So again, like 12 inches is 1 foot. That again is an equality, which means that it is meaning the same amount, but on different units. And from any equality, you could write 2 conversion factors. You could write 12 inches over 1 foot, or you could do the opposite, 1 foot over 12 inches. Again, each of these are considered conversion factors. We use them in this type of calculation. And the most important thing to remember is opposites cancel. And what that means, it's really like a fraction type system. If the unit you want is up on top to get rid of, you need to put that same unit on the bottom in the opposite location. If perhaps the unit you want to get rid of is on the bottom, you need to put that unit up on top so that they cancel. So opposite locations, like over here with unit A, even though it's not really written as a fraction, you could think of it as being over 1. So unit A is like up on top, which is why we put the unit A in the opposite location. Because mathematically what we're doing here is multiplying everything on the top and dividing by everything on the bottom. So essentially what we're doing is we're taking unit A divided by unit A, which basically equals 1, which means they essentially cancel out. It's the same thing if you divided 2 by 2. Those guys should cancel out and equal 1. So if you have the same unit on top and the bottom, they will cancel each other out. It's basically dividing by the same unit. Any questions on that so far? So here are some equalities. And again, from every single one of these equalities, we could absolutely write 2 conversion factors. So for example, if we chose this one here, we could write 1 pound is 16 ounces, or we could do 16 ounces is 1 pound. In this particular case, and in most cases, thank you very much. In most cases, we will not use both in the calculation. So for example, obviously, if I said, hey, if I have 62 ounces and I want to know how many pounds that is, I would start with the 62 ounces. I want to get rid of ounces. So again, even though it's not really written as a fraction, we could clearly see here that the ounces are up on top. That means I should use which conversion factor, one on the left or one on the right? I will need the one on the left here. At least it's my left. I hope it's yours as well. Because ounces are on the bottom, so opposite cancels. So what we would do is put on the bottom 16 ounces, and up on top would go 1 pound. Again, what we're mathematically doing is we're multiplying what's on top. So we're multiplying 62 times 1. We're then coming back and dividing by what's on the bottom, which is 16. When we do that, we're essentially dividing ounces on top with ounces on the bottom, and they will cancel each other out in this case. That will leave us just pounds that are left in terms of our units. And if we want a number, oh, that is not good. What just happened here? Oops, go on here. All right, so 62 divided by 16. That's going to give us an answer of 3.875. The units here would be pounds. Now, let's talk about significant figures. And again, that is found by taking 62 times 1 and then coming back and dividing by 16. Significant figure-wise, this is coming from an equality, which is considered an exact number. And that means we don't have to worry about significant figures with that one, which means really the only number that we have up there that has anything to do with the significant figures is our original number here, which is 62. That has how many significant figures? Does have 2, which means really my answer should end up there at the second significant figure. I look to the right there, that's a 7, which means we should end up with 3.9 pounds. Again, in this case, like most problems, you never use both conversion factors in the same problem. Otherwise, you just undid what you did, right? You basically went backwards. But you do want to pick the one that would work. So wherever the unit you want to get rid of is, on top, on bottom, you need to put the same unit in the opposite location, and they will cancel out. This is really what dimensional analysis is, this sort of setup where we can see the units, we can see which ones are canceling out, and it is a skill that you're supposed to obviously learn and how you're supposed to do these type of problems. Any questions on that there? Yeah. Yeah, so let me just clean it up maybe here a little bit so we can kind of see. Get rid of, oh, that didn't work. Want an eraser, there you go. Or not. All right, I don't want to erase, but I'll rewrite it over here. So we have 62 ounces, and this is really the math that we did right here, which is the 1 pound over the 16 ounces. So what we're dealing with here is basically we did only multiplication and only division, right, in this whole process, which means we should be looking at significant figures like we talked about. Now, when we look at significant figures, we look at this guy, which is a conversion factor that comes from an equality, and that's considered an exact number. So as we talked about, exact numbers can have really as many significant figures as you want. So because they technically could have as many significant figures as you want, we typically ignore them in calculations. Otherwise, everybody will go, I want to give it like 30. I want to give it 1. You know, everybody will come up with different things. So typically, if we come across something that's considered an exact number in a calculation, we kind of ignore it in terms of significant figures and trying to figure out what our answer should be. So since we're going to basically ignore this guy, the only number that's left in the problem really is the original number, right? And the original number has 2 significant figures, which is why we would want to take our answer to 2 significant figures. And this is sort of what I was saying a second ago, that if you do pretty much a conversion problem, you know, everything in the middle of the calculation most likely will be considered an exact number, which means probably 9 times out of 10, again, it's not 100 times, but 9 times out of 10, probably that original number, if all you're doing is a conversion, probably is the right number of significant figures your answer should have, or pretty darn close to what the right number of significant figures should be. The one exception would be if you found somebody really picky, that again, if you had a conversion factor in the middle, that was again a conversion between metric and English, you should look at it, you know, like 454 grams in a pound or something like that. You should look at the 454 and go, it's got 3 significant figures, and take that into consideration. So for example, if we had that one in here, we would still actually go back to the original number, which again, in a lot of cases is what sort of happens. Other questions? Okay. So equalities, you know, we do see them everywhere, you know, even on labels of food, you know, they go, here's some ounces, and then there's some metric. So English and metric really does sort of cross over a lot when we look at things. Equalities and significant figures, as I mentioned before, we pretty much consider an equality to be an exact number, which the beauty of that is we basically could ignore it. Again, as long as it is, technically speaking, a metric to metric conversion, or again, an English to English conversion, or US to US. It's really when we do cross over, you know, between those two that you should look at it. The one exception that we come across is the 1 inch is 2.54 centimeters. That's English, that's metric, but that's what's considered an exact equality. So that's sort of an exception to that rule. But again, if you cross over, you really should take them into account. The good news of that is really you could ignore most conversion factors that you use in terms of significant figures. And like I said, that usually will bring you back to sort of the first one. Now, when equalities consist of metric and English, one of the numbers of the equality is obtained by a measurement. So here's the one I was just talking about. You know, technically speaking, if you use this as a conversion factor, which you could either use it as 454 grams over 1 pound or 1 pound over 454 grams, technically speaking, you should kind of take a look at that and go, okay, in my calculation, that's 3 significant figures. You know, that might be relevant. So for example, if we started at a calculation of, we'll just say, you know, somebody weighed 175.5 pounds, you know, we wanted to know how many grams that was. Here we would start with the 175.5 pounds. Which conversion factor should I use, left or right? It is the one on the left, right? We want to get rid of pounds, which again, even though it's not really written as a fraction, technically speaking, is up there on top. So we would want to use the 1 pound so that they cancel. The 454 grams, pound cancels. And in this case, probably why they don't give it in grams, but kilograms, but we'll go with grams on this one. It looks like on my calculator, 79677 grams. Now, significant figure wise, the first number had how many significant figures? 4. Now this is our crossover, which as I said, is obtained by a measurement. And you should technically look at it. So this guy has how many? 3. By the way, when you look at one where you should take it into account like this, the one that's 1 is not the one you should look at. You should always look at the one that's bigger than 1, like the 454, like the 946. You know, those are the numbers you should look at. That means technically speaking, my answer should end up with not 4, but 3 in this case, which would take me here. We do want to round it up there. And we could go with 79700 grams, or if you wanted to, you could obviously write it in scientific notation in that particular case. Let me get out of the way there. Yeah. It is going to be incorrect. So we talked about this, I think, last time as well. You want to really watch out your rounding, right? So people, again, it's very common in this class or when people learn about significant figures is they have in their head, like, I got to get the right sig figs, right? And 797 would definitely be the right number of sig figs. But as we talked about, there's a very big difference between the real answer here, which is 79,700 and 797. So although you hit the right number of significant figures, you actually change the meaning of the number. So remember, you never want to round where you actually change the actual meaning of the number. So you would want to leave, obviously, those 2 zeros. I don't want to put a decimal point because then it would have 5, right? If I put it at the end. The other way you could answer, like I said, is you could do scientific notation, which would be something like 7.97 times 10 to the 1, 2, 3, 4 grams, and that also would have 3 significant figures in this case. Question on that? So that is the one sort of exception where you do need to kind of think about the significant figures in a conversion factor. But I will say a lot of times, more times than not, even looking at those, the first number a lot of times does have the least number of significant figures. So, you know, but just keep that in mind. On the bottom, there's the exception that we talked about, that 1 inch is 2.54 centimeters. So again, that's considered an exact conversion. So if you use that conversion for something, you don't have to worry about it in terms of significant figures. Any questions on that there? I'm sorry? Yep, okay. All right, so conversion factors, as I mentioned, is really, you know, it's really fractions, and it's really a way to go, nothing more than really trying to convert one unit into something else. Now, a lot of times you may have units on both the top and the bottom that you want to convert, not necessarily one or the other. So it's really important to set this stuff up with dimensional analysis and showing the units so you understand where the units are. So although you may not want to do it, you should do it, and you want full credit, you need to do it. But it is really helpful to you to set it up like I was showing you with the units. It is a very common mistake when people don't do that. They have no idea really where the unit is. So what a lot of times will end up happening is people will multiply when they should be dividing. They'll be dividing when they should be multiplying by numbers. And if you set it up so that you can kind of see the units, you'll be in pretty good shape. Here, obviously, 1 hour is 60 minutes. Here's our 2 conversion factors that we could use. So for example, let's say we had, you know, feet per second. And we'll just, let's make up a number. We'll go with 255 feet per second, right? Whenever you have a unit that says something per something, that's basically 2 units, like you're driving miles per hour, right? We'll do that. Why not? We'll change this to, what is it? Miles per hour, right? Now, usually when you have like feet per second, the number stays with the first unit. So the 255 feet technically stay together and are on top, and it's per 1 second on the bottom. In this particular case, you can look at this as really 2 conversion problems you need to do. We need to take the feet to the miles, and we need to take the seconds to the hours. Now, setting it up like this, where we can clearly see feet are on top, seconds are on the bottom, we know really where we should put the conversion factor. So we'll just throw in some conversion factors here. There's 5,280 feet in 1 mile. And there are, we'll just do a simple, we'll do it. Obviously, we could see 60 minutes in an hour. And we also know that there are 60 seconds in 1 minute, right? So from each of these, we could get really 2 conversion factors. We could have 5,280 feet over 1 mile, or we could do the opposite, 1 mile over 5,280 feet. Same thing with our 60 seconds in a minute. We could say there are 60 seconds in 1 minute, or we could say up on top, 1 minute is 60 seconds. Yeah. And then clearly we have this guy right here that we could use as well in this problem. So if we were to do this problem, you really just want to kind of take 1 conversion at a time. So let's say we started with 255 feet per second. I'm going to start with the feet. And the way I wrote it, I could clearly see my feet are starting on the top or bottom, which means if I want to get rid of feet, I should put it on the, which means I should use this conversion factor to do that, right? The feet are on the bottom. So that would be my first step here. 5,280 feet per 1 mile. If I stop the calculation right at this point, the feet would cancel, right? Feet would cancel, basically feet divided by feet. The units I would be left with are what units at this point? Miles on top per second on the bottom. So by just doing that 1 conversion, I have already taken care of the top part. Everybody clear? Yeah. Now, if you want to, you can get an answer, or you could just continue on with the calculation. I'm going to continue on with the calculation. And this is where the advantage of setting your thing up like dimensional analysis is. At this point, I want to go from seconds to hours, basically. By the way I set it up, I could clearly see that my seconds are on top or bottom, which means to get rid of my seconds, I need to put seconds on top. And this is really critical. I can't tell you how many people will start dividing by those numbers instead of multiplying. So what we would use, obviously, is seconds up on top, which would be this one. And we would just continue on. Again, you could get an answer. If you get an answer, you might not want to round like we talked about, obviously, to the end. And we go here. Now, at this point, what units cancel? The seconds on top, the seconds on the bottom cancel. The units we're left with is on top is miles, and on the bottom is minutes, which is close to what we want, right? We want to now go from minutes to hours. The benefit of this is we could clearly see where's my minutes, which means to get rid of the minutes, I need to put minutes on, which means we want to use the one on the left here, which they provided. And that would be our last step here. Up on top would go 60 minutes. On the bottom would go 1 hour, same deal, minutes on top and minutes on the bottom would cancel. The units we're left with is miles. This is the only one standing up on top, which is good. And the only unit left on the bottom is, which is good as well, because that's what we're looking for. Math, first off, any questions on the setup there? Yeah. Mathematically, what we're doing is we're going to multiply all the way across the top. So I'm going to take 255 times 1 times 60 times 60. I'm going to hit equals. I'm going to divide it by 5280, and really nothing left to divide because they're all ones. You could if you want, nothing will happen. And if we do that, 255 times 60, hit equals, divided by 5280. And I believe, I'm going to look at that one more time. I think that is a comma on my calculator here. Let's say that is 118,000. We end up with it's at 173. That's a decimal, right? Okay, I'm getting old. I see something there. I can't tell if it's a decimal or not. I think it is a decimal there, which is 8636 and a bunch of numbers going on there. Okay, now the units here would be miles up on top. So I'll rewrite it down here. Actually, we'll clean it up at the end. Let's talk significant figures. What should my significant figures be? Should be 3. Again, exact number, right? And that leaves us really just our original number, which was 3. Should take us here, which means we technically should round up. And we should end up with 174. As I was saying before, the units that are left is miles up on top per hour, yeah, on the bottom. Yeah. So the number always stays with the top unit, and the bottom unit is always 1. Yeah, so it's basically this. Question on any of that stuff there? I think we talked about the other day, right? You should know some conversions, right? Like time, right? And there's, as we talked about, only 24 hours in a day. Again, a very common mistake. Now, this is I put this one up because it's very common. People will not necessarily set it up like this, which you should be doing. And like I said, they will just go, okay, feet per second, and they'll write it like this, like 255 feet per second. And basically, nobody knows what they're supposed to be doing with, like, where's the second? Should I be multiplying? Should I be dividing? And I can't tell you how many people will do seconds on the bottom here, or, 60 on the bottom and 60 minutes on the bottom, because they can't really see where all the units are. So you want to make sure that you set it up like this so you could clearly see, what unit is on top, which one's on the bottom, so that you could pick the right conversion factor. Any questions on that? Here are some common equalities. Here's some of our metric to metric ones. Again, this column pretty much means in a calculation, you don't have to worry about significant figures. From any one that you pick off of this list, you could write 2 conversion factors. Here's our US or English to English. Again, this is the column where you do need to look at the significant figures. Again, except for obviously the one here, that's the exact, but everybody else, you do need to make sure that you look at it. Again, some of these we will come across a lot. Obviously, grams to pounds is one that comes up a lot. Milliliters and quarts seem to come up a lot in chemistry. And then, as we talked about, I think the other day, kilograms, grams, milligrams, those guys, do come up a lot. Most of these will be provided for you. Again, like I think I might have said the other day, if you look through the review sheet, it will tell you specific ones that you technically should know by heart. So just make sure that you know those, like the 1 inch is 2.54 centimeters. I don't know why everybody likes everybody to remember that one, but they seem to do. All right. So looking at these guys again, we sort of covered this here. Metric to metric conversions, again, are 2 conversion factors, which again are just simply fractions, and we will not use either one of them. Here's a crossover. So in this particular case, if we were to use technically these conversion factors or one of them, we would want to look at this number here in terms of its significant figures, and just to make sure that, maybe that's not the least number of significant figures that you got going on there. All right, so we'll take a look at these. You probably maybe not memorized all these. So let's take a look at some of these here and just to see where we get them. This one is 1 liter is 1,000 milliliters. That definitely is one that comes up pretty much daily. So you use that a lot in chemistry. And obviously those are our 2 conversion factors. That's where we could write it from. Here is 39.4 inches is 1 meter. And on the bottom there is our 1 milligram is 1,000. And again, I don't know why books kind of bounce back and forth, but sometimes a symbol that they use for micrograms there as well. Now, I will take a note on this here, and I think I talked with some of you on discussion about it. When you're really going from like a prefix to a prefix in conversions, sometimes people want to try to figure out, how many decimal places and stuff like that should you move. And people kind of want to do it in like a 1-step situation. I highly recommend not doing that. Again, a lot of people will mess that up. The good news is if you look at this, like meters and meters is really the unit that ties them both together. That's the base unit for both. It's really a better move to go from kilometers to meters, because that conversion you can find really easy on a table. You just need the kilo conversion, right? And you can easily find on a table meters to centimeters, which is just the centi conversion. And it's much better to do kind of 2 conversions there and make sure you do it right, rather than trying to figure out, all right, well, that's like move the decimal through this way, that way, and you're going to probably mess up. So I highly recommend, if you're doing some type of conversion where you're going from really a prefix to a prefix, use the base unit as sort of your middle point, take it back to the base unit, and then convert it from the base unit out of that, and you usually will be okay in terms of the calculation. Any questions on that there? Okay. All right, so an equality may also be stated within a problem. So for example, if you're given that you are driving 85 kilometers per hour, you can turn that into a conversion factor, and it works the same way. Basically, you could go 85 kilometers over an hour. Our 1 hour is 85 kilometers, which means if I drove, 800 kilometers, we'll do it like that, 800 kilometers like that, I suppose. We would use the conversion factor where The kilometers would be on the bottom, which would be 85 kilometers. And up on top would be 1 hour. And if we do that, the kilometers would cancel. And that would tell us basically how many hours it would take us to drive if we're driving on that speed. And that is 800 divided by 85. And on my calculator there, that is a 9.41176, whole bunch. Hours would be the units. What should the significant figures be here? It should be 2. Again, technically speaking, when I put the decimal there, that has 3. This is really not a, I'll put it this way, not a true equality for every situation. Like, what I mean by that is 12 inches is always a foot no matter what the situation is. You may not always be driving 85 kilometers per hour or whatever it is. So that's sort of a one where you would want to look at the significant figures. And in this case, we would look at the 85, which has 2, which means technically speaking, this guy should end up at 9.4 hours. Yeah. Question on that? So sometimes you are given numbers in problems. You can use it as a conversion factor, but in a lot of cases, they are sort of, if you want to think about it, specific for that problem. So not a always situation. So you would still always want to look at the significant figures when you have a number like that in a problem. Any questions on that there? Yeah. I just made it up out of the, yeah. Then I realized I put a lot of zeros. I should put a decimal there. Yeah. Other questions? Same thing here. A tablet contains 500 milligrams of vitamin C. That again is something that you can turn into a conversion factor where you would write 500 milligrams of vitamin C over 1 tablet, or a tablet is 500 milligrams. Again, here, this is specific because, you know, they make tablets, for example, that's 1,000 milligrams perhaps, right? So, you know, this is not a true exact number all the time. And we would want to look at the significant figures here. And in this case, the way it's written, it actually has 1 significant figure, which is probably going to beat everybody else in that calculation if you were doing a conversion. And that's what you would want to end up with. So again, very common. Sometimes we do pull conversion factors out of problems. Those you do have to look at the sig figs because they're, again, not a always sort of conversion for sure. Now, percentages, right? A lot of times we're given things in percentages. The easiest way to sort of turn a percentage into a usable unit is to assume that you have like 100 of something, right? So if you got like a 90% on your exam, that probably means you got like 90 points out of 100, right? So it's an easy way to turn a percentage into sort of a usable conversion factor. And that's something we do a lot in chemistry. And the reason we choose 100, you could technically choose any number you want, but the reason we choose 100 is it doesn't change the original number, right? So it stays the same. So if we had somebody that was 18% body fat by mass, that basically means, for example, that is 18 kilograms of body fat per 100 kilograms of body mass, are the opposite. You could also do it like in pounds. That would mean how many pounds would that be? 18 pounds per 100 pounds of body fat, right? I'm sorry, body mass. And our 100 pounds of body mass per 18 pounds of body fat. So you could do it with that one as well. You can choose any units you want. The ultimate goal here is you take 18 divided by 100, then times it by 100, it's 18%, right? No matter what the unit really is in that particular case. So that is a very, very common conversion and a very good way to really turn a percentage into sort of a usable sort of conversion factor, is just to assume 100. And it keeps the number the same, makes it really simple to use. Sometimes doses as well. It's kind of like the one we just saw before. So Keflex, 250 milligrams per capsule. Again, That 250 is a measured value, which means you do need to take it into consideration when you're doing a conversion. So, probably, like I said, 95 times out of 100, if you're doing a conversion, that original number is probably the right sig figs. But there are a few cases where you need to sort of think about the conversion factors that you're using. Two main places, what we're talking about here, some type of conversion that comes from the problem that's not like a 12 inches a foot always going to be the same. And again, something where it crosses over from metric to the English system, you should take those into account. All right. So we'll just take a look at these here. Meters and decimeters. In 1 meter, there's 10 decimeters, which again allows us to write our two conversion factors, which is our fractions. Here's our 18% gold. That means basically there's 18 grams of gold in 100 grams of the jewelry, or 100 grams, there's 18 grams of gold. Again, you could have done grams, you could have done pounds, I suppose, and so forth, whatever sort of unit would work there. And 1 gallon of gas is $2.40. Yes, please. Surprisingly, it's probably really expensive when they wrote that, I suppose. But I haven't seen that like for a long time. But it's $2.40 is 1 gallon, and 1 gallon over $2.40. I don't think you can get that in Arizona anymore. $2. Yeah, you got to go further. Everybody's like, yes, we'll go there. All right. So let's talk about, again, using these. As I mentioned before, you should get into a habit of setting up your problems like we've been doing some of these examples where you can see the units canceling. Again, it's really what's referred to as dimensional analysis, and it is how you're supposed to work out some of these problems. There are several steps to these problems. Sometimes it's really helpful to obviously identify sort of the information that's given to you in the problem. Also, it's kind of important to figure out what you're trying to find. You want to think about how you're going to really get from one unit to the next. So you want to think about what equalities you want to use. You also want to think about the conversion factors that go with them and which ones you want to use. And then obviously you should set up the problem where you're showing the units canceling, like we've been doing, and obviously give the answers the right number of significant figures. Now, conversion problems, there are multiple ways you could do the same conversion, sort of depending on what equalities you sort of choose or what pathway you choose. So technically speaking, if you choose, if there's multiple ways you could get to that final unit, as long as you choose correct and legit conversion factors, not ones you make up, everybody should get to the same number at the end. You just may be taking a different path. So as you go through these problems, there are different paths. So for example, the one where we just did a second ago where we did the seconds, right? We ended up going from seconds to minutes, minutes to hours. You could, if you know that there are 3,600 seconds in an hour, and just kind of leapfrog to that, and it'll get you to the same spot. So there are sometimes multiple ways you could kind of get to the same conclusion, but the end result really should be, kind of the same for everybody when you get there. All right, what body mass is in kilograms? So we want to think about the conversion between pounds and kilograms and how we're going to get there. So the first thing that we want to do really is think about, we are starting in pounds. We want to get ourselves to kilograms. So obviously we would want to look up in a table. If you don't know the conversion, there is actually a conversion between kilograms to pounds, and we would want to use that to help us do it. We are crossing over here, US to metric, right? Pounds is sort of English or US, and metric obviously is the kilograms. So we want to think about our equalities that we want to use. So obviously here we could find this on a table where we have 1 kilogram is 2.2 pounds. That again is our equality. And these two guys here are our conversion factors. Now, we would start here with the 178 pounds, and clearly we can know by our conversation, pounds are here on top. which means to get rid of pounds, we would want to put the pounds on the bottom, which is why they chose to use this conversion right here. That again, just like we were doing a second ago, will allow our pounds to cancel. And that will leave us with kilograms, which is essentially what we are looking for. Again, here in terms of the math, we would be multiplying 178 times 1, and then hitting equals, coming back and dividing by 2.2. In this particular case, we have a couple of things that we need to look at in terms of significant figures. We got 178, which, as you can see here, is 3 significant figures. Because this is going from English to metric, we need to look at the actual number, which is the 2.2, which in this case also has 3 significant figures. So that means our answers should end up as they got there, and I'll trust them hopefully. It has 80.9 kilograms, which should have 3 significant figures. And again, here you can see, as I mentioned before, we're clearly not using both conversion factors. We just really want to pick the one that works the best and has the units in the opposite location of what we want. Really, that's all dimensional analysis sort of is, or conversion problems, is really just going from one unit you don't want to some units that you do want. And we use these conversion factors to get us there. Any questions on that particular one there? All right, why don't you just go? Rattlesnake is 2.44 meters long. How many centimeters is there? There is 100 centimeters in 1 meter. So why don't you give it a go, see what you come up with. Okay, so again, from this one equality, which is what this is, again, that's the equality, which is our 2 guys that are on different units. We could obviously write 2 conversion factors here, which would be 100 centimeters over 1 meter. Are 1 meter over 100 centimeters. In this case, we would be starting with meters. So we'll start with 2.44 meters. That means my meters are on top, which means meters should end up on the bottom, which means we're going to go with this guy here. 1 meter on the bottom, 100 centimeters there up on top. That is going to cancel our meters and leave our centimeters. And we will end up with 244 centimeters. Is that the right number of significant figures? It actually is in this case. This is a metric to metric one, which means we don't have to worry about it. That means the only number that we got going on there is 2.44 meters, which is 3 significant figures. And we should end up with 3 significant figures. By the way, you know, this is where we could use that centi, right, which as we saw from the table is 10 to the minus 2. That would mean that there is in 1 centimeter 10 to the minus 2 meters, and we could have used it like that, which is kind of the same thing. And you will end up with 10 to the minus 2 meters in 1 centimeter, and you'll end up with the 244 centimeters as well. That again is, if you wanted to punch into your calculator, technically 1 times 10 to the minus 2. Again, on most calculators that have like the EE button or EXP button, you could actually just hit the exponent button and minus -2. On those other ones, you might not actually type in 1 times 10 to the minus 2. Any questions on that? Yeah.
Where did that decimal go for the, you know how it was like 2.44?
Yeah.
The answer is just 244.
So 2.44 times 100 gives you 244. So when we do the multiplication part, yeah.
I'm divided by 1. Oh.
Yeah. So you'll end up with 244 basically divided by 1, which is still 244. Yep. Other questions? Okay. All right. Let's see if they agree. Hopefully they agree. That's good. All right. All right. So again, as we also did in that sort of earlier example, you definitely will sometimes need to use more than one sort of conversion factor to get you there. You know, in most cases, you know, maybe 3 conversion factors usually will get you to, at the most, to like where you want to end up in terms of units. If you find yourself doing like 400 conversion factors, you're definitely going down the wrong path along the way there. But, you know, usually 2 or 3 conversion factors will, in most cases, sort of take you from one unit to the next. Usually not a ton of them, but we do sometimes use them together. And as we did in that previous example, you can just continue on the calculation as sort of one whole calculation if that's easier for you to do. You may also be more comfortable getting an answer than doing the next conversion, getting an answer, do the next conversion. There's really nothing wrong with that. Again, just you want to watch the rounding till the end. So take each answer, if you do it sort of in pieces, make sure you take it to a good number of significant figures as you carry that answer, across. And when we do have, something like this, so we'll take a look at this. A doctor ordered prescribed at doses of 0.15 milligrams. If it only has 50 micrograms tablets in stock, how many tablets are required to get us there? So in this particular problem, we have a couple of issues. One issue is we do have a conversion factor here, which is basically that it is 50. I'm just going to do micrograms like that per tablet. Right? Or you could do a tablet is 50 micrograms. And those are two conversion factors that we really could get kind of from what's in the problem here. The problem is the doses that we want is actually in milligrams. So you really have an option here of one of two things. Probably the easiest option would be you would probably want to convert that to milligrams. So then you can just use these conversion factors the way they are. The other option would be you would have to convert the conversion factor into milligrams, and then you could use it that way. But you do have to do a conversion because basically our units of mass here are different. So you got to get somebody into the right units so that the conversion factor works. We'll follow their path here. I think they're going to go milligrams to micrograms, would make sense. In this case, you would need to sort of look up, in this case, milligrams to micrograms, or try to figure it out. So here is our conversion factor from our problem. Here is, they're nice enough to give us one between the two. 1 milligram is 1,000 micrograms. And that's what they did. So they started with the original number, which was in milligrams. And really the first conversion that they did was solely to get it into the right units. So again, you could have, if you wanted to, did this as a separate calculation, got an answer. And then they can now do it because at this point, the first thing that would cancel is milligrams. And we would be left with micrograms. And now we could use our conversion factor where it goes from micrograms to tablets. Those guys then would cancel. And we end up with basically 3 tablets here. Now, in terms of significant figures, the milligrams to micrograms, that's metric to metric, so we wouldn't worry about it. Technically speaking, the one that they gave us here is a measured value, so we should look at it, which is 2 significant figures. And this original guy has 3 significant figures. Technically speaking, if we were going based on significant figures, we should end up with 3-point-something tablets. My guess is they rounded it off because you're not going to probably break the tablet in half. You're just going to give the person probably 3 tablets to go. That's pretty close enough. But if we were strictly going by significant figures, really the answer should have how many significant figures? Should have 2 significant figures in this particular case. So, they do obviously in this particular example, looks like they did a little rounding there. I would say in our case, you probably should give it as really, it actually is 3. The answer 3.0 would probably be the correct way to do it, which would have 2 significant figures. Any questions on that there? Yeah. All right. All right, so give this one a go. How many minutes are in a day? Or 1.6 days, actually. There you go. And again, set it up dimensional analysis where you can see the units and all that good stuff. Okay, let's take a look here. So again, you might want to come up with a game plan. So clearly we're starting, no, we're starting in days and we want to end up in minutes. So again, you might not want to take the direct route, or maybe you do. We probably would be easy to go from days to hours, right? And hours to minutes is a good sort of game plan there. We would start with 1.6 days. So if I use my conversion factor, which hopefully we know from days to hours, there's how many hours in a day? And that should go, 24 hours should go top or bottom here. It should go top, 24 hours, 1 day. Again, at this point, the days would cancel. We would be left with hours, which now we can use our knowledge here of hours and minutes. There's how many minutes in an hour? And minutes should go top or bottom. Minutes should go top here, 60 minutes and 1 hour. Hours will cancel. And if we go across there, 1.6 times 24 times 60 gives us an answer on our calculator, 2304 minutes. Significant figure wise, what should we end up with? We should end up with 2. Again, exact, don't have to worry about it. This number we do need to worry about, which is 2. That takes us to here, which means probably like 2300 minutes would be good. Or again, you could use scientific notation if you wanted to. Any questions on that there? So again, for credit, obviously, yes, you need to show the work. Yes, like this, if you want all the points. If it helps you, you could write out the equalities, you could write out the conversion factors. You don't necessarily have to do it. You can write what you're trying to find and all that. So whatever helps you, you could do it. But minimum, in order to get all the credit, set up like this, correct answer, sig figs, yes? And that's what you need to show. Questions on that? So hopefully they agree with us. That's good. They do. So that's good. All right, let's try one here. If your pace on the treadmill is 65 meters per minute, how many minutes will it take you to walk 7.5 kilometers? Let's see what we need here. We'll go with kilo is 10 to the 3. All right, take a moment, see what you come up with. Let's take a look. So 65 meters per minute, that's what we often refer to as a rate, right? It's kind of how far you're going in a certain period of time, distance per time. This is the distance we want to go. This is a conversion factor to 65 minutes per hour that we would take from the problem here, and we could use it either way if we needed to. We do have a same issue as we talked about a second ago. Our distance here, one's in meters and one's in kilometers. So we do need to do a conversion. So I'm personally going to take the kilometers to the meters, so I could just use the conversion factors the way it is. So that's what I'm going to do first. I'm going to do 7.5 kilometers. All right. So kilometers and meters. Where does the 10 to the 3 go? On the kilometers or the meters? It is the meter. So that's 10 to the 3 meters is 1 kilometer. So you want to make sure, again, that you do that correctly. Kilometers does need to go opposite here. So it does need to go on the bottom. The 10 to the 3 meters are 1,000 is what that is, goes up on top. Kilometers here will cancel, and we will take 7.5 times 1,000 basically. And that gives us 7,500 meters. Any questions on that so far? That now allows us to be in the same unit as our conversion factor from the problem. So should I use the conversion factor on the left or the one on the right here? We should use this one, right? So we have meters that are on top. We want to get rid of it. So meters is going to go opposite. 65 meters per minute. That's really going to convert us from distance now to unit of time, which is what we're looking for. And we'll take 75, we'll then divide it by 65. There, 7,500 divided by 65 on my calculator, 115.3846154 minutes. Should you give all those numbers? That's a good answer. How many numbers should you give? Is that a question? I think you're right, because all the numbers that we see on the page there, they're all 2, right? We should look at both of them. Again, this conversion factor is one that we kind of got specifically for this problem, so we should look at it. It does have 2 significant figures. Our original number had 2 significant figures, which means we should end up with 2 significant figures, which means the answer should be, it should be 120, no decimal, minutes. Question on that there? Yeah. Yeah. Did we multiply? Is that what you're asking? We did not. So basically, we're going to take the 7,500 and multiply it by 1, and then come back and divide it by the 65, which is on the bottom. Yeah. So basically, when we set these up in dimensional analysis, whatever's on top, they all get multiplied. So every number on top, which again is the reason why you should set everything up like that, so you could clearly see, okay, I need to multiply all these numbers, and everything on the bottom is where you're going to divide all the numbers by, so you could clearly see it. Other questions on that? Yeah. I got the 120 because based on our calculation, this had 2 significant figures.
But you know how it's the original.
This had
like 115.384. How did you get 120?
Yeah, so the answer should end up with 2 significant figures, which if we look at our original numbers here, this is a 5, which means we should round up.
Oh,
And instead of 115, it would round up to 120. Yep.
5 is a 0, right?
It does, yes.
So you wouldn't just cut off the 5.
You wouldn't in this case, because 5 or higher, you round up. Anything less than 5, you just drop the numbers.
Oh.
Yeah, so for example, the question is, you know, we round up because this is a 5. If it happened to be like 114,
So
we would make it 110. Yeah.
So you, oh, okay, got it.
Yeah.
So you still keep that, you still convert that third number into 0? Like you
We do, because again, if we just write 12, there's a big difference between 12 and 120. Yeah, yeah. Yeah. Other questions? Okay. All right, let's see if they agree. That's good. All right. All right, why don't you give this one a go here? You hit the local AM PM, you grab yourself 32 fluid ounce drink. How many gallons did you drink? I'm going to give you some equalities, some conversion factors, so see what you come up with. All right. So 32 fluid ounces, how many gallons did you drink? Okay, let's take a look since we're getting towards the end here. So we're starting with fluid ounces. We want to get to gallons. My pathway here is to go from fluid ounces to quarts and quarts to gallons. Here's the appropriate sort of conversion factors to get me there. I'm going to start with the original number, which is 32 fluid ounces. I clearly want to get rid of my fluid ounces, which is on top. So I would go to my conversion factor, and I should use the one on the left here to do that. Again, the fluid ounces are opposite. So up on top would go 1 quart, and we would do 32 fluid ounces on the bottom. If we stop the calculation right at this point, fluid ounces would cancel, and we would be left in quarts. Now, by setting it up like dimensional analysis, I could clearly see my quarts are on the top, which means to get rid of the quarts, I need to put the quarts on the bottom. So that clearly helps me really visualize that I should be using this conversion factor next. And again, you could have got an answer if you wanted to, or you could continue on, which is what I'm going to do here. 1 gallon is 4 quarts. Again, quarts on top, quarts on the bottom will cancel each other out. We are left with gallons, which is what we want. We're going to take 32 times 1, hit equals, or you can leave off the ones if you want. And then you should go divide by 32, hit equals, divide by 4, hit equals, and you should end up with 0.25 gallons as your answer. Significant figure wise, really everybody's kind of exact numbers except our original number, which was 2 significant figures, 2 significant figures. Now the answer is not 1/4. That makes me think you're too lazy to divide. Yes. So don't leave it as a fraction. That's not a terrible example, but I've had people leave answers like 325 miles over 125 hours and just kind of box it. Yeah. So don't do that. Divide it out, get an answer, decimal to the right number of significant figures, and we should be good. Any questions on that calculation there?